Hello geometry peeps, welcome to another amazing day of learning geometry, and today we're talking about our angle theorems, and the first one we're going to start with is the angle sum theorem. And the angle sum theorem is one that we were already familiar with, but to formally state it, it's the sum of the measures of the angles of a triangle is 180 degrees. Always, 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 if it's a triangle and it exists, the three angles add up to 180. So to show, let's call that angle x degrees, this angle y and z degrees. And it would say x plus y plus z equals 180. And we can use this fact to solve many different types of problems. Alright, so let's try two of them real quick. And my first example, let's say this is triangle ABC. And we'll say angle A is 4x plus 9. Angle B is 7x minus 13. And angle C is 2x plus 2. Now, we know it's a triangle, and we know it exists, so we know the three angles add up to 180. So let's go ahead and do that. Angle A plus angle B plus angle C, well, I don't want to write C, plus 2x plus 2 is equal to 180. So they sum up to 180 degrees. Let's combine my like terms. 4, 7, and 2 give me 13x. 9, negative 13, and 2 give me minus 2. Add my 2 to both sides. 13x is 182. Divide by 13, and x is 14. 182 divided by 13 is 14. Now we could substitute the value in for x and find any angle measurement we wish if it asked us to. Now over here, let's try something different. Let's see if we can apply this. So I'm going to tell you, this one is 42. This one is 84. I'm going to tell you, this is an isosceles triangle, and I want you to find angle x. Alright, so first let's start with what we know. We know this triangle. We know one angle is 42 and one angle is 84. So I could go 180 minus 84 minus 42, and that gives me 54 degrees. So we know this angle here is 54 degrees because this is one triangle here. Alright, now if that's 54, we know we have vertical angles, so we know that's 54 because vertical angles are always congruent. And from there, we now have to solve the rest of this triangle. Now, we know if we have an isosceles triangle, if the sides are congruent, then the base angles are congruent. So if this is x, I could call this x. So if I take 180 minus 54, I'm left with 126. So I know these two angles together sum up to 126. So if I divide 126 by 2, I get 63. Alright, so that means that both of these angles would be 63 degrees, and in this case, angle x that we were trying to find is also 63 degrees. Okay, so just applying it and taking it a step further. Alright, so that's the easy theorem. Now for the other theorem. Now this is called the exterior angle theorem. Now, the measure of an exterior angle of a triangle is congruent to the sum of the measure of the two remote interior angles. Let me say that again. The measure of an exterior angle of a triangle is congruent to the sum of the measure of the two remote interior angles. Say what? Now you're probably thinking, wow, he's talking fast. Well, that definition is not going to make too much sense to you until I go ahead and explain it. Now, we're going to call this angle x, we'll call this angle B, angle A, angle B, and angle C. Now the theorem is going to say this: the measure of the exterior angle of a triangle, so the first part, that we're speaking about angle x. So the measure of angle x, exterior angle of a triangle, it's on the outside of the triangle, is congruent to, so is equal to, the sum of the measure of the two remote interior angles. The two remote interior angles are the two interior angles that are not adjacent to my x. So it's B and C. So it's saying that the one on the outside is equal to the sum of the two on the inside that aren't adjacent to my angle. Now, this theorem, that's the theorem as it states, but let's go ahead and explain it and why this exactly works. So let's say this is angle x, and we'll keep this B and C. So I'm going to tell you that this angle measures 60 degrees. Now that's an important fact to help us explain this. So let's just look at the triangle. Now, I know you'd all believe me if I said B plus C plus 60 equals 180 degrees, because up above we said the three angles sum up to 180. So that's a true fact. Now let's just focus on these two. Now together these two make a straight line. So we also know that x plus 60 equals 180 degrees, because together these two angles make a straight line. So if you kind of look at this, if I subtract 60 from here, I get B plus C equals 120, and I subtract 60 from here, I get x equals 120. Now, of course, they match. Now think about this. If these two together always equal 180, and if these three together always equal 180, this guy is shared with both. Alright, so if those two add up to 180 and these three add up to 180, and you take out the common piece, then the leftovers have to be equal. And that's where this theorem comes from. So if these two add up to 180 and these three add up to 180, then of course in the result they're going to be equal. Alright, so that's our exterior angle theorem, and that's why it works, because they both sum up to 180. And this is the theorem you got to be able to apply. So let's take a look at our last example here. I'm going to tell you this angle is 100 degrees. This angle here is 2x plus 3. And this angle here is 51 degrees. Now, just using the theorem, it says the exterior angle is equal to the sum of the remote interiors. So I could say 100 is equal to 2x plus 3 plus 51. So let's go ahead and solve. So 100 equals 2x plus 54. Subtract 54. I get 46 equals 2x, which means x equals 23. Now let's just go check this. Now, we know if this is 100, these two add up to 180. So 180 minus 100, this would be 80 degrees. Now if x is 23, let's go 2 times 23 plus 3. Well, that's 46 plus 3 is 49 degrees. Now if we add up 49 and 51, we get 100. Plus 80 is 180, so that triangle works. 100 times 180 plus 180, that triangle works. 49 plus 51 equals 100. Our theorem checks out too. So, that's all I got. See you later.